Hello friends, welcome to my channel Q Analysis, and I am your host Prashant Kumar. And today we are going to start with my webinar on machine learning, artificial intelligence, and its uses in software testing. So here we go. So the agenda for today's webinar would be something like this. What is AI and ML, artificial intelligence and machine learning? What are different approaches of machine learning? What is the difference between supervised and unsupervised learning? I'll explain the concepts, all these concepts with example. Then we'll see why AI and ML are to be used in software testing. What is the use of AI and ML in software testing? Moving next, human versus artificial comparison. So human intelligence versus artificial intelligence. How can we compare it, and what are the pros and cons, what are the benefits and drawbacks? We'll compare on those lines. Last but not the least, I'll cover the topic impact over software testing, the impact of artificial intelligence, machine learning on software industry in coming days. So this was the agenda, and let's move on to our first slide. Here it is. So to start this webinar, I'd like to ask a question to you. So you can see my screen, and there are rows from 1 to 6, and each of the rows, they have certain objects in them on the left side, and then on the right side, I have 4 different objects for you, and there's a question waiting which says, which group does this object belong to? Take a moment, think about the answer, please. Okay, now, as most of you would be knowing what exactly is the answer and to which class or which group these objects are going to belong, let's move on to the second part of this question. The similar kind of image on the left, but this time we have a different object waiting for you on the right side, and this object is also asking you the same question: which group does this object belong to? So I hope you got the answer in both the cases. So when we say machine learning or artificial intelligence, what exactly it is? Being human, we can clearly identify both the scenarios. The objects given over here, apple, cow, horse, and pear, all these things, they belong to the category we can see on left, and then we can see on right and determine, okay, this object looks like this, it has features like this, it has characters like the other object, and then we can segregate object depending upon the features and looks, because we have a sample data to refer, okay, which is known as training data. And in the second one, the object on right has no reference in left, but the object on right is also available and it is there to be segregated. So this is a different kind of learning in which we try to figure out on our own, without knowing the test data, if we have something which is unique or which has a unique features, and depending upon the features of that item, we create our own memory, we create our own decision, and then we decide where to put it. These are few examples of machine learning, which is known as supervised and unsupervised learning. I'll explain it more in my upcoming slides, but this was just an activity to start with my today's presentation. So, what exactly is the difference between artificial intelligence, machine learning, and deep learning? This is a question which I keep on getting on frequent basis from a lot many users and lot many of my followers and readers. They keep on asking me this question. For me, artificial intelligence, machine learning, or deep learning, they seem to be very much similar. This is what people they say on regular basis. Even for normal users, this is what they think. I agree to some extent, but since we are into the technology side and I belong to the IT industry, I'm giving you a brief explanation of what exactly is artificial intelligence, what is machine learning, and what is deep learning. Artificial intelligence is the bigger set. It is the main set which has machine learning and deep learning as its subset. So the artificial intelligence is the superset of all technologies that enable computers to mimic human intelligence using logic, if then rules, decision trees, and machine learning, including deep learning. Yes. So any kind of technology which enable a duplication of human intelligence in computers, it is known as artificial intelligence, in simple words. Now, what is machine learning? Machine learning is a subset of artificial intelligence that includes abstruse statistical techniques that enable machines to improve at task with experience. The category includes deep learning. So, it is a subset of artificial intelligence in which machine improved uh, they get improved kind of decision making experience depending upon the training or the data they have, and it is based upon deep learning. It is also Deep learning is also a part of machine learning. Deep learning is a subset of machine learning composed of algos that permit software to train itself to perform tasks like speech and image recognition by exposing multi-layered neural networks to vast amount of data. I understand all these things. They seem to be very much techy and so much of technical information in it. So don't worry. Moving on to the next slides, I'll try to keep the things simple so that all of you should be able to understand what exactly I mean to say when I talk about artificial intelligence or machine learning. Okay, so here we go. Let's talk about a little bit of history. So artificial intelligence, it actually came into picture in early 50s and 60s. In between of early 50s and 60s, this came into picture. The early artificial intelligence stirs excitement. It was mostly about enabling machines to do the things on their own and programming machines, which later on increased into something like robotics. And then in early 90s till 2010, we had this machine learning coming into picture, where so many different kind of algos and approaches and different kind of theories were discovered and invented in order to begin machine to start learning on their own. And then from 2010 onwards, a new field which is a subset of artificial intelligence, and machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning, which started in early 2010, and now it is on a great boom. And I guess most of the fast growing institutions like Google, Facebook, everybody, they are using this deep learning and neural networking techniques in order to gain lots and lots of human data and use it in order to have a very high impact decision making thing. So what exactly is machine learning? In very simple words, I'll tell you. We have set of training data, like we have training sets in which different kind of data. As you know, right now the biggest currency is not money, data is the biggest currency. Recently we had this Facebook issue, and till now it is going on, and people were so pissed off because the data was not secure. So you know how important it is, and you know what exactly is the use of the data. That data can be used by different companies in order to figure out what they can know your exact schedule, they can know about your preferences, your choices, your pattern of behavior, and what exactly is your thought process. So depending upon, since Facebook keep on collecting all those data, and if that data goes into hand of some kind of organization, they can do a lot of predictive analysis, they can do a lot of data analysis, and applying unsupervised or supervised machine learning kind of concept, they can go ahead and figure out lot many decisions which you're planning to do, or which you think you will do. And depending on those decisions, they can know those decisions in advance. It is like predicting the future. The companies would already know what kind of decision you are going to take in a given certain situations. in a controlled set of environment, if certain parameters they are provided to you, what would be your reaction? Because they know in past you have done something like this, and you have a set of data. Your data is with them. That every time when you are put into such kind of environment, you take certain kind of actions. If companies they know all this thing, they can predict it. And this is what is done as a part of machine learning, where data is provided, feature extraction takes place, and applying machine learning algo, different kind of decision is being made, and group of objects is then arranged, or different kind of decision is implied on those group of objects, and then a predictive model is calculated, and this predictive model is then rolled out for the users from which data was taken, so that now companies can figure out, they know in advance that if such and kind of things are given to you, you'll always act in a predefined predictive manner. Now, these are the different kind of areas where machine learning is so much impactful, and it is so very much applicable. So I'll tell you about these areas where machine learning is getting more and more involved nowadays. So you see, machine learning has divided into three different approaches. First one is unsupervised learning, second one is supervised learning, and third one is reinforcement learning. So in supervised learning, you have classification and regression. So when we talk about classification, yes, you understand it correctly. Image classification, identity detection, customer retention diagnostic, all these approaches, they use classification technique under the supervised learning of machine learning. And then similarly, in terms of regression, advertising popularity prediction, weather forecasting, market forecasting, estimating the life expectancy, population growth prediction, all these things, they come under regression of supervised learning under machine learning. Similarly, in unsupervised learning, you have big data visualization, meaningful compression, structure discovery, and feature elicitation. All these things they come under dimensionality reduction of unsupervised learning. And then you have a second approach, which is known as clustering, recommender system, targeted marketing, and customer segmentation. They come under part of clustering. All these approaches, they use clustering mechanism of unsupervised learning. And under reinforcement learning, the kind of approaches of machine learning, what is developed, it can be utilized for game artificial intelligence, skill acquisition, learning task, robot navigation, and real-time decisions. So these are the different kind of, right now in current industry, current real-time scenario, these are the different practical implementations of machine learning and different techniques of machine learning in different aspects of human life. I'll explain more about all these techniques in my upcoming slides. So let's move on to the next one. So we had a lot of technical jargons, topics coming in, and things were getting really heavy. So here we have something which is very important, a bit of humor. So look at this. We have the boss, and he says, based on your internet history, you might be dumb enough to enjoy extreme sports. This is what he's getting from his computer. You might be dumb enough to enjoy the extreme sports. Click here to buy a ticket to base jump from International Space Station. And this is what computer is suggesting. At the same time, he's saying that you're dumb enough to enjoy extreme sports. And then boss goes back, and this is what he thinks. I think the internet is trying to kill me. And here we have the master stroke coming. We call it machine learning. Yes. So depending upon your data inputs, the machine knows what kind of decision to take for you and what kind of solutions to be shown to you. Okay, friends. Then moving on to the next slide. Here we are talking about supervised versus unsupervised learning. So in my last slide, last to last slide, we talked about the different kind of approaches of machine learning. The most important approach, which is being used in today's IT industry or software industry on a very massive scale, is supervised and unsupervised learning. What exactly is supervised learning? As the name suggests, supervision, where you have something to supervise you, and unsupervised, where you don't have somebody to supervise you. So in supervised learning, the knowledge of output, that is, learning with the presence of an expert teacher under his supervision. Data is labeled with a class or value, goal, predict the class or value. An example is neural networks, support vector machines, decision trees, Bayesian classifiers. All these are examples of supervised learning. And now, what is unsupervised learning? When no knowledge of the output class or value is present and data is unlabeled or the value is unknown, and even then, your goal is to determine the data pattern or groupings, and all it has to be done via self-guided learning mechanism or algo, and this is known as unsupervised learning because you don't have anybody to supervise you. And then all you do is internal self-evaluation against some criteria and figure out a self-guiding mechanism. Example, K-means, genetic algorithm, clustering approaches, all these are example of unsupervised learning. Now, I understand these things are for somebody who is new to this artificial intelligence and machine learning concept. For them, it might be a little hard to understand. So, I have decided to come up with an example which is very simple yet very effective to understand these concepts. So, let's move on to our example. What do you see over here? Come on, take a full view. You can see a basket lying on a table, lying over a table, and then it has some fruits. It has banana, it has grapes, it has apple. So different kind of fruits are there. Three different kind of fruits, broadly three different kind of fruits are over there, and then it's lying over a basket, in a basket over a table. Now, if somebody asks you, you have to classify these fruits separately. How do you do that? Let's do it using machine learning, and we have two different approaches. One is supervised learning, and the other is unsupervised learning. So let's see how are we going to segregate these fruits on the basis of supervised learning. You already have a training data from your past experience about the physical characteristic of food. When I say supervised learning, you have certain training data and you have certain kind of supervision, right? So in this case, we know a certain amount of data. Okay, what is the color of banana? Banana is generally yellow or green, and then size is circular and cylindrical and a little curvy. Same way, we know apple is generally red in color, and then it is big in size. It's not small, it's medium or big size, and it has a little amount of 100 200 gram of weight, and then it is little tapering from both the ends. Same way, grapes are very small in size, maybe 10 or 20 gram, and then they are mostly green and black in different colors, and they're circular. So we know different kind. We have this different kind of information regarding size, color, and shape of that particular food. If the size is big, color is red, and shape is rounded with depression at the top and bottom, then you can say that fruit is apple, and you will put it in apple group, right? This is known as supervised learning. Now we'll apply the same techniques whenever we have a fruit. We see it, we take its size, color, and shape and different kind of features. Depending on that, we compare it with our training data and then apply the knowledge to our test data, and then we figure out where can we place this object. This kind of learning, this kind of application of learning is known as supervised learning. Okay, so you have a test data, you compare it, and you figure out, depending upon your test data, you figure out certain parameters, and if those parameter matches to your training data, then you say your test data is equal to this training data, so they might be same, and hence you segregate them, or hence you implement that kind of functionality. So it is known as supervised learning. So in this way, we can segregate um, apple, grapes, and banana using supervised learning if we have a previous data or test data with us, training data with us. Now, if we have to do the same segregation using unsupervised learning, how are we going to do that? So this time we don't know anything. You don't know anything about the fruits. We don't have any data regarding fruits. How will you arrange them? Now, and this time we'll take one of the list, we'll take all those fruits one by one and we'll try to learn without any supervision. So we'll learn on our own experience. Then we'll group some, let's say we'll arrange the fruits on the basis of color. For example, if the color is red, red color group is apple and green color group is banana and grapes. Now we'll take the second physical characteristics such as red color and big size is apple, green color and big size is banana, and green color big size and cylindrical is banana, green color and a small size is grapes. So here we had no information from past, no training data, no response variable, but still we are learning on our own and there is no supervision, but still we can learn depending upon the features or characteristics what we have decided to use in our decision making process. Such kind of learning is known as unsupervised learning. Now, with this, we come to a very important slide which talks about different kind of questions which most of you would be having regarding artificial intelligence and machine learning. What if the software could learn to test itself? What if the software could automatically track and eliminate the bugs? Will artificial intelligence and machine learning kill software testing? Now, these are the questions which are so much in demand nowadays, and people they are trying to figure out answer to this question, and everybody is interested to know what would be the outcome. They want to know about. They are asking questions and they want to know answer to these questions. So, in my upcoming slides, I'll try to answer these questions, and hopefully, I'll be able to answer them correctly. Let's see. So, what is software testing? If if you ask a layman, if you ask somebody who is not having any experience, or if you ask somebody who is having a lot of experience, this is what you're going to get as an answer, which is common from both the person, which is testing means applying certain kind of inputs, doing some kind of process, and finding some output. And these outputs should be verifying this output or checking this output that this output are as per the expectations. Means actual output and the expected behavior and the actual behavior, if they both are matching, then we'll say our tests are passing. This is known as software testing. And what is software testing using artificial intelligence? We do the same kind of thing wherein we have input, we have inner layer wherein we provide different kind of data parameters, and then we have a hidden layer which does the different kind of processing of data. Now, when I say processing of data, like for example, in supervised learning, we had information from past, and then we compare the new data depending upon the past training data and figure out test data is compared or is processed in terms of the training data, and then we figure out our decision making process and try to decide come up with the output. And in unsupervised learning, we don't have any training data and we collect the data on our own depending on the different kind of situation, depending on different kind of parameters. We figure out our own data and we figure out our own learning, and then we come up with a decision which is output. So it is same, we have set of input and some actions are taken or some algo which does the kind of processing, and then we have output. And this output, if the expected output is equal to the actual behavior, then we say tests are passing. If actual and expected behavior is same, then tests are passing. If at all there is any difference, then the tests are failing and we report it as bug. This is what is software testing using artificial intelligence. Now, why artificial intelligence and machine learning are going to be so much involved in software testing and software development? Why do we need it? Means, okay, things were going good, everything was nice, people were getting job and we were doing things. Then why exactly we needed artificial intelligence and machine learning in software development and testing? To answer this question, I'll tell you the kind of application what we used to have, let's say 20 years back, and now the kind of application we used to have are the same? Absolutely not. We see so many good application nowadays, we see so many implementation, we see so high standard app nowadays which are doing so many different kind of things and functions for us, and which has been, all these applications have made our life so easy. The only thing which is required from this app, the only expectation is they should be high standard, quality wise, and performance wise. And how can it be ensured? It can be ensured by testing. Now, with increasing features, the complexity increases exponentially. Yes, that's a proven fact. Whenever you have a new feature or enhanced feature coming into picture, the complexity, simple things are not very complex and they're very easy to test. But whenever we have some complexity coming into picture, the new features coming into picture, the complexity increases exponentially, and new features, they have a lot of features to be tested. So test coverage should also increase exponentially, but it cannot happen if you're testing manually or if you're testing it using some normal standard procedures which you used to use for testing the earlier application, and even for the enhanced or high level application you're trying to use the same kind of testing mechanism. That is not going to work. There'll always be a coverage gap. So within a given point of time, you want to increase the complexity, you want to increase the feature, but at the same time, in given time, your coverage is not going to increase if you're going to follow the same kind of testing activities and you're going to follow the same testing process and technology. And hence, there is certain need of high level technology in testing as well. And this is why we have artificial intelligence and machine learning coming into picture when we talk about software development and testing, and to increase the coverage and to cover maximum number of test cases, to figure out everything has been covered and tested thoroughly, we do need artificial intelligence and machine learning. What are the different kind of career opportunities in artificial intelligence and machine learning? I keep on listening to where this statement very often. People say due to machine learning or artificial intelligence, people will be losing their job. There will be no more job. Robots should be doing everything, and machines will get very smart, and then there is no need of human labor or human testers or manual testers. So job would be gone. To some extent, that is right. And why it is right, I'll let you know in my further slides. But to some extent, it is wrong. It is not completely right or completely wrong. Completely wrong because somebody who is not learning new techniques and who are not going to improve themselves, the whole of the ecosystem is changing, right? The way you used to go for a medical treatment, let's say 20, 30 years back, and now they have changed. The way you used to use transportation few years back, and the way you are using transportation now, they have changed. The manufacturing industry, the energy industry, the retail industry, the financial sector, banks, every telecom, every sector has changed a lot in last 20, 30 years. So the way you used to test them earlier and the way you're planning to test them now, they should really change. And if you're not learning those techniques, there is no point that you can sustain in the changing environment. You'll become dinosaur of today's IT world if you're not learning to adapt. That is a fact. But if you are ready to learn, if you're ready to adapt, then there is an enormous opportunity. There is a huge set of opportunities for you. You can give, you can get so many opportunities made with manufacturing industry. Like in manufacturing industry, you have this predictive maintenance or condition monitoring, warranty reserve estimation, um, propensity to buy, demand forecasting, process optimization, and telematics. These are different kind of areas where in manufacturing you need artificial intelligence. And when I say artificial intelligence, it is not only just development. It requires testing as well. It requires automation. It requires testing of the different kind of velcros. It requires data analytics. It requires different kind of result verification. It requires business analysis. It requires user acceptance tests. It requires database testing. It requires performance testing. So there are different kind of testing which will be required in manufacturing sector. Similarly, in retail sector, predictive inventory planning, recommendation engineering, engines, upsell and cross-channel marketing, market segmentation and targeting, customer return of investment and lifetime value. So all these fields, they will require lots of testing when it comes to machine learning and automation, or maybe the artificial intelligence. All these things cannot be implemented overnight. You have to develop and come up with a artificial intelligence environment which should be able to perform and do some learning on its own. But who will do it? Somebody has to do it, right? Somebody has to develop it, somebody has to test it. And who can test it? Who has the knowledge of this kind of testing? So there's a huge set of opportunities. Trust me, if you're ready to learn new things, there's a huge set of career opportunities for you waiting. And then this is a very important slide which I'd love to share with you. This talks about the new technique which is going to be used in software testing on regular basis. In upcoming days, till now, we used to have a set of uh, standard procedures and learnings, and they were stringent, and we used to pass certain kind of certification, learn it, and use it in our day-to-day life. But now this is no more going to be relevant. The whole approach will change, especially in the field of software industry, not only for development but also for testing and support. The whole software system will be based upon discover, learn, sense, and respond mechanism. Now, what is discover, learn, sense, and respond mechanism? It is something like, when I say discover, create a smart asset using data repositories which has defects, tickets, logs, etc. that can be used for analysis. So you should have a data repositories, real-time data, user data with different kind of requirements, tickets, information, logs, issues that can be used for analysis. Depending upon this repository, identify the causal relationship between test assets such as defect and software requirement document for developing insights. So you have to come up with your learnings. You have to create relationships between different assets and then figure out the different kind of insights based upon those learnings. After discover and learn, the third step would be sensing. Predict the occurrence of an incident, impact and likelihood led by the analytics and insight. So once you have the insight, apply analytics and you can figure out, you can predict when could be the occurrence of the next incident and what could the impact and likelihood. So once you have discovered, learned, and sensed out, then you have to come up with a response mechanism, which would be something like responding to an incident, input the resolution and result for the continuous learning. And from this, again, this is a cyclic manner. You have a knowledge base which keeps on working with all these four process: discover, learn, sense, and respond. So over here, you optimize the pattern by matching the test cases, logs, or requirements, and then you learn on the basis of your discovery by predicting the quality defect by analyzing log defect tickets and social data. You sense out the insights and then trigger automated responses, script to test, and targeted features. This sensing generated trigger, they are used for response, and this response is based upon the knowledge base, and again it ends up into getting different kind of source model information from log defect and tracking codes, which led up to discovery, and this becomes a continuous process. So discover, learn, sense, and respond is going to be the main source or main mechanism which is going to be used for machine learning in IT industry or artificial intelligence in IT industry, including software testing. Now, with this, we come on to our next slide, which talks about human versus artificial abilities. Now, everybody talks about nowadays, robots should be like, as you have seen in so many Hollywood movies, that robots are like superhumans and they can do anything. Yes, I agree. Robots are speedy, they are accurate, they have high efficiency, good performance, and they have logical ability. And in coming years, all these things will enhance more and more with the help of artificial intelligence, machine learning, and deep learning. No doubt, things will go ahead very fast. But then humans have their own set of good characteristics or a unique characteristic USP, such as they have a kind of intellect. They can figure out the planning, like they can roll out different kind of plan depending upon their intellect. And this intellect is based upon IQ and EQ, emotional side, and as well as the intelligent side. Robots, they don't have the emotional side, or the artificial intelligence is not based upon emotions, but humans, they are based upon their IQ and EQ. Human beings are spontaneous and they have a creative side. Like you see, we have created robots and artificial intelligence techniques. So how creative human beings can be, right? This is the biggest example. But trust me, there are so many things which, like for example, if you have something which is repetitive task and which is boring task and which doesn't require any kind of human intervention, why to waste human labor or human mind or human effort in such kind of task? They can be done by artificial intelligence based machines or robots or maybe somebody else. Why should a costly human brain be used for such kind of activities? It can be taken care by machines. But if at all there is something which requires a lot of spontaneous activity, creativity, and use of emotions or use of different kind of advanced brain techniques, then of course human are the best person to use it. For example, exploratory testing. Exploratory testing is something which can be conducted best by human brain as of now. So why to use robots or machine learning based systems for exploratory testing? No point. Because if you lose and there's a issue, if machines they fail or if there's a issue, it will end up into a huge disaster. I have given out a previous presentation in my previous webinars or my other videos from my channel. You'd be seeing. If you have not subscribed to my channel, please do so, because I on daily basis I keep on preparing a lot many videos on software testing and quality analysis, and you have different kind of topics being covered. Please feel free to subscribe, like, and share my channel. And you can let me know in comments different kind of topics you want to get covered. So in one of those topics, one of those videos, I have talked about why quality is so important in today's world. You cannot miss to have any kind of bug in any of the system, because it can lead to a loss of human life or huge amount of financial loss. So everything has to be perfect, and hence you can divide the role among humans and machines. Wherever something which is repetitive, which is non-productive, boring, and you don't find it good, or it is very labor intensive, or something which can be done by machines in easier way, just give it to them. But if at all you have something which is innovative, spontaneous, creative, or which involves a lot of emotion around, or which requires active decision making, you can use humans for that purpose. The best example would be exploratory testing. For exploratory testing, human testers or manual testers are the best one. And for regression testing, where you have to repeat the same testing again and again, automation testing using machine learning is the best example. Impact over IT industry or software industry. What would be the impact of machine learning and artificial intelligence on software industry? We are already seeing a lot of impact. Like things are changing. The way things used to happen 10 years back, now things are changing, may it be in terms of IT production, development, or deployment, or testing. In all the fields, a lot of changes have taken place. And then I can surely say, with artificial intelligence becoming more and more enhanced and improved, there'll be options to help software testers and provide users with a top quality products delivery. And this will be applicable not only to testing roles but to all the software development roles and software delivery roles. Once the initial investment to set up an AI system in test automation is made, the organization will be able to generate greater testing rewards for less money. Yes, once you have the artificial environment set up and testing can be done via automation, you can get greater return of investment. AI can free testers' time for repetitive tasks to focus on more interesting and creative parts of software testing. Yes, this is what I was saying in my previous slide. And survival of the fittest. Yes. If you ask me what is one thing which I would like to emphasize over this webinar or through this webinar, then the only thing which I'd like to emphasize would be survival of the fittest. Always remember survival of the fittest, and you can do it by adaptation using learning, or else you will be eliminated. Adapt to survive, or else get eliminated. This is the nature's rule, and this is truly applicable in today's IT industry and other sectors as well. Things have changed. 30 years back, all these automotive or manufacturing industries, they used to employ a lot many labor intensive industries. And then robotic arms and machines, they came into picture. People were just let go, and then everybody was moved out of their job. They were fired, and these machines started working. And now everything, all this manufacturing industry, just few hundred people, they manage the whole industry, and everything is taken care by robotic arms and mechanical devices, mechanical things, and things are working on a day-to-day basis on a very fast and very natural way. Nobody cares about those labors, right? Things have changed. IT started in 1980s, and this is 2018. So it is more than 38 years it has been working in the picture. So I'm pretty sure in due course of time things will change. The way it is not going to be the same. People doing software courses and coming into market, working as developer, tester, programmer, or support engineers. Okay, it was fine up till now, but now things are changing, and the same is not going to happen anymore. If you're not learning new techniques, if you're not learning new features, how to enhance your skill and how to become more and more productive, I guess you'll be eliminated. Trust me. So never stop learning. This is my piece of advice. This is my single piece of advice to all you viewers. Please, please keep learning. With this, we come to the end of our presentation. And this is me, Prashant Kumar, QA evangelist and software test enthusiast. And you know about me, I've done my computer engineering PG specialization in management from Harvard University and ICMS Sydney. I have almost 12 plus years of experience. I started my career as a Java developer, then business analyst, then test consultant, and finally quality head at a major IT firm. I have worked with investment banks, startups across USA, UK, Switzerland, and Germany and India. And all these things which I have gained in the last few years, I'm just trying to share with my colleagues, my friends, and my viewers. And this is the motto of starting this channel. Please feel free to like, share, and subscribe my channel. And you can get in touch with me regarding any QA-related query, suggestion, mentoring, or consulting opportunity. You can get in touch either by LinkedIn, or you can just follow me over there at LinkedIn or subscribe to my channel. Soon I'll be coming on Twitter as well. Thank you, friends. Thanks a lot. Have a good day. Bye bye. See you next time.